Hello again. In this video, we are going to talk about how to solve the questions in other exam files. Two probability questions we will solve. Yes. First question. A fleet of 11 taxis is to be randomly assigned to 3 airports, A, B, and C, with 4 going to A, 4 going to B, and only 1 going to C. The rest remains at the center. In how many ways this can be done? Use binomial coefficients. What's the probability that a specified driver Jones is assigned to airport C? Firstly, how many ways that can be done? I'm writing what I have. 50 taxis. 3 airports, A, B, and C. 4 taxis to go A, 4 other taxis to go B, and 1 other taxi to go airport C. 4 for 1. And how many taxis I have to send to 3 airports? It's 9 taxis. So, like I've explained already in the last video, but I will mention briefly again. I need to choose firstly 9 taxis from 11, because I need to choose which taxis will go to the airports. So that's the way this combination 11 chooses 9 times multiplied, because all of the selections are happening at the same time. I need to choose 4 taxis for airport A from 9 taxis that will go to the airports. 9 chooses 4 times. I've already chosen 4 from 9. I have 5 taxis at remained. 5 chooses 4 for airport B times. I have 1 taxis at remained, and I will choose 1 for airport C. That's the possible ways. Equal 34,650 ways to assign these taxis to go to 3 airports, A, B, C. Second part. What's the probability that a specified driver Jones is assigned to airport C? Now, like I already explained again in this video, for special selections in a special case, we need to choose that case firstly. I need to choose I need to choose Jones. I need to assign Jones to go to the airport C at first. 1 chooses 1. I have only 1 Jones from 11 taxi drivers, and the way that I can choose Jones is 1, and that's how to show with coefficients, combinations. 1 chooses 1 times. I have 10 taxis remained, and I need to choose 8 of them to assign to 3 airports, because normally I need to choose 9, but John is in that 9. I already selected John's, so I have 8 drivers remained. Sorry. 10 chooses 8 firstly. I already chosen Jones, so I have 10 drivers, and again I already chosen Jones, so I have 8 drivers to choose instead of 9. 10 drivers times. I need to choose 4 drivers from 8, because which airport Jones? C. Okay. 4 drivers for A, because I need to have 4 drivers to go to the airport A times 4 drivers remained, and I need to choose other 4 of them remained for airport C. 8 of them have been already chosen. Why? Because I have one person, one driver to assign airport C. That's John, only one, and I've already chosen John's here. Hence, I've already selected John's here. I don't choose John's again, so that's the possible ways. That's here. Favorable outcomes over possible outcomes. 19 chooses 1. I've calculated in first question, in first part. 9 chooses 4. 5 chooses 4. 1 chooses 1. That's equal to, what's it? 0.0909090901. That's the probability. That's the how to solve first question. That's the second one. Okay. An assembly operation for a computer circuit board consists of 6 operations that can be performed in any order. I need to check what I have, but the question is, in how many ways can the assembly operation be performed? That's the same question with last video, but I will explain. 8 operations I have. Okay, 8 operations. The order is not important. 6. How many ways? That's the first, that's second operation, third, fourth, fifth, sixth. Order is not important, so I have 6 operations to assign one of them to first, one of them to second, and goes like that. 6 chooses 1. I will choose 1 operations for first from 6. 5 remained. Multiple depth selections are happening at the same time. 5 chooses 1 for second. 4 remained, and 4 chooses 1 for third. 3 chooses 1. 2 chooses 1, and 1 chooses 1. What's that result? It's 6 factorial. What's the probability that a specified driver Jones? Different question, sorry. That's the possible ways, and it's equal to 720. One of the operations is soldering. If all possible orderings are equally likely, what's the probability that soldering comes first or second? Right. I will draw it again. 6, yes. Soldering comes first again, right? Soldering comes second or first. Right, yes. Soldering is here or here. Okay. I've already chosen soldering. How many operations are remained? 5, right? 5 chooses 1 for second. 4 chooses 1 for third. 3 chooses 1 for fourth. 2 chooses 1, and 1 chooses 1. What's it? It's 4 factorial. No. It's 5 factorial. For here, the same. 5 chooses 1, 4 chooses 1, 2 chooses 1, 3 chooses 1, 1 chooses 1. It's 5 factorial also again. It says or, this happening at a time and these selections happening at another time. So I need to sum them to find how many ways are there. It's 2 times 5 factorial, and the possible ways is 6 factorial. To find the probability from naive definition, 5 factorial over 6 factorial, 1 over 6 times 2, 1 over 6 times 2, it's 1 over 3. That's 0 point. That's important. Okay. That's all for that video. Thanks for listening and watching.